back. We're looking at the Chapter 2 extension topics, and the first one we're going to take a look at is something called a fractional exponent. Yeah, so you've been dealing with exponents in Chapter 2, and one of the rules that hopefully you remember using is this exponent law for multiplication. So remember this one? If I have something like x to the power of n times x to the power of m, do you know how that is simplified or put together? That's like, for example, x squared times x to the power of 10. Do you know what that was? Yeah, you added the exponents together to give you x to the power of 12. So this is the same thing as saying x to the power of n plus m. So we're going to use this idea to figure out what's going on with these things called fractional exponents. So notice that in part A, if I have 7 to the power of a half times 7 to the power of a half, that would be the same thing as 7 to the half plus a half. And what's a half plus a half? That's right, that's 7 to the power of 1, or just 7. Well, if I had root 7 times root 7, hopefully you know that that's actually equal to root 49. But root 49 is actually the same thing as 7. Hey, look at this. Both of these answers equal to 7. So if they are both equal to 7, therefore, what do we know? Well, I guess this piece must equal to this piece, and that piece must equal to that piece. So therefore, I think what you've concluded is 7 to the power of half is the same thing as the square root of 7. Interesting. Okay, now let's take a look at the next one. 7 to the power 1/3. We're going to have to multiply that with 7 to the power 1/3. And multiply that with 7 to the power 1/3. So what do? We add the exponents together. That's the same thing as 7 to the power 1 or 7. When I have the cube root of 7, I can put them all together. That's root 7 times 7 times 7. That's actually root 343. And the cube root of 343, you guessed it, is 7. And since the answers to both expressions above are the same, I guess I'll say this, are the same, because they're both equal to 7. I think this was supposed to be are the same too. And the answer was 7. Therefore, yeah, what do you notice? That 1/3 and that cube root must also be the same. So 7 to the power of 1/3 equals to the cube root of 7. So let's look at one more. 7 to the power of 1/4 times 7 to the power of 1/4 times 7 to the 1/4 times 7 to the 1/4. Well, that's the same thing as 1/4 plus 1/4 plus 1/4 plus 1/4. That's 4 quarters, or 1. And the fourth root, well, that's root 7 times 7 times 7 times 7. That's 2,401. And if you use your calculator, guess what this is going to be equal to? You got it, 7. And just like the previous one, since the answer to both expressions above are the same, what do we know? 7 to the power of 1/4 is actually equal to, the fourth root of 7. So, when we have fractional exponents, that's always a numerator of 1 over n, where n is a whole number. That's equivalent to taking the nth root of the actual number. So the exponent form, if it was x to the power of 1 over n, that is equivalent in radical form, the square root form, as the nth root of x. Okay? It's in a box, so it's important. That's the key idea for today. So knowing that, can you try some of these? So I want you to simplify this without a calculator. Now, it's nice if you can change this to radical form. So 64 to the power 1/2. That's the same thing as the second root of 64. The second root is really just the regular square root. So what's the square root of 64? Yeah, just 8. Now this one, the 1/3, that's equal to the cube root. So it's the cube root of 0.064. Now you might not know this, but yeah, the answer is just 0.4. If that wasn't nice, you could rewrite this as a fraction. That's 64 over 1,000. And then you could have just taken the cube root of 64 over the cube root of 1,000, and you should be thinking, the cube root of 64 is 4, the cube root of 1,000 is 10, 4/10, that's also 0.4. Okay, so the same. Something tricky with a negative here, but don't worry, same idea. power of 1/3 is the cube root. So you're asking what number multiplied by itself 3 times is equal to negative 125. And if you wrote down negative 5, I'd be very happy. And then finally for part D, don't freak out about fractions like I showed you in part B. This is the same thing as the square root of 16 over 9, which is the same thing as the square root of 16 over the square root of 9. That's 4 over 3. Okay? So, are we pretty good with this? 1 over something, it's just the root. But now let me mess you up and try something different. Let's look at another exponent law that you hopefully remember from your studies in Math 9. The power rule. X to the power of n times m. That's like me saying 3 to the power of 5 all squared. What was that equal to? If you said that's equal to 3 to the power of 10, you are correct. So really what you need to do is multiply the two exponents together. Now this is nice because I can now look at fractional exponents that don't have a numerator of just 1. Let's look at 125 to the power of 2/3. I said rewrite the fraction as a whole number multiplied by unit fraction. So what I mean by that is write this as a whole number, so the whole number will be 2, multiplied by a unit fraction, which is a numerator of 1, so that will be 1/3. Okay? Now knowing this, remember the cube root is the 1/3, so it's the same thing as 125 squared. I guess I can use my calculator now. Bring it out. Hello, calculator. I gotta do 125 squared. That's a big number. 15,625. And then I'm gonna take the cube root of that. On my calculator, it's under math. Choose number 4. 15625. Notice what you get now is 25. Okay? Now, that's one way of doing it. But there's another way we can split this up. 125 to the power of 2/3, I can rewrite it as a unit fraction times a whole number. In that case, it'd be 125 to the power of 1/3, then raise this to the power of 2. Okay, just using the exponent law. But if I do it this way, this is equivalent now to the cube root of 125. And then I'm going to square that result. And the cube root of 125, yeah, that's 5. And so 5 squared, yeah, that's also 25. So from the above, hopefully you can see that the numerator of a fractional exponent, so that's the 2, right, represents what? We always had to do a power. That's right, a power. And the denominator, that would be the 3. What does that represent? Yeah, the cube root. So that represents a root. So note that the root and the power can be evaluated in any order. It doesn't matter about the order. But which order do you think is actually easier? Is it the one on the left or the one on the right? The one on the left, we squared it first, and then we took the cube root. And then the one on the right, we took the cube root, and then we took the square. I think it's actually easier to do the root part first. Why? Because it gives you a smaller number, right? Because it gives you a smaller number. And then with the smaller number, then it's much easier to square it. Then easier to take a power of a smaller number. Okay? So once again, both ways work, but don't you want to do the one that's a little bit simpler? I do. So in general then, if I asked you here to say, if I have x to the power of m over n in the equivalent radical form, that's equal to the nth root of the x, and then all raised to the power of m. So one of the things I like to remember here is this thing called flower power, because x to the power of m over n, I think of that as like a flower. And when we draw my flower here, whee, here's my flower. So it's flower power because the top number is the power. And look, the bottom root, it's a root. I know it's a stem, but I like to call it the root. Okay, so top number is the power, the bottom number is the root. And so now, understanding that, let's see if we can actually find the exact value for these questions. No calculators, please, okay? Once again, flower power, so the bottom number is the root. So in this case, this is the square root of 16. You can put a 2 if you want, but most people in math just say square root. And then we can raise it to the power of 3. Square root of 16 is 4. 4 cubed is 64. Okay. Now, once again, you could have done the other way. You can just cubed it first and then take the square root, but that's just a big number. Let's not go there. All right. Let's try B. This is flower power, so the cube root of negative 27 raised to the power of 2. The cube root, of course, just equals to negative 3. And be careful, negative 3 all squared, then, of course, gives us positive 9. Now you may be thinking, hey, where's the fraction here? Well, you can always change 2.5 into a fraction, can't you? Yes, you can. That's 2.5, or as an improper fraction, 5 over 2. So this is equivalent to 16 to the power of 5 over 2. No problem, you're saying, because I know that it's the root, and then raise it to the power of 5. That's 4 to the power of 5, which might be a little bit scary, but I know that that's 1,024. Okay? All right, let's see if we can do the next ones. This should be now the root of 9 over 25, all cubed. So the square root of 9 is 3, the square root of 25 is 5. We're now going to cube that. That becomes 27 over 125. Okay. By the way, these shouldn't be negative exponents. Just write them as 3 over 2. Okay, 3 over 2. And this is just 5 over 3. All right? So I think I've done enough practice here. I want you to try these two. And then once you're done, come back and double check your answer, because I think you've got this by now. All right? So prove it to yourself. You can do it on your own. Think flower power. Yeah, you should have pressed pause, right? Remember? Press pause. You do it first, then come back and check. Are you happy? You got the same answers as me? Bravo if you did. That's it for this video. Come back again.